My name is Mariusz Postal. I want to invite you to participate in the upcoming course on external data management. It is part of the educational path called Programming in Practice. Programming in Practice is a discipline that systematically applies engineering principles to the design, development, and implementation of algorithms, program text editions, and testing. It is a component of the software engineering discipline, covering sequential, adaptive, concurrent, real-time, and distributed programming. It also includes external data management. The main goal of this lesson is to provide an introduction that allows you to decide if this course is well scoped and could benefit your career. Generally, during this lesson, you will learn the title explanation, the course's scope, and student prerequisites. By design, each lesson will start with an explanation of the main problems addressed by the lesson in question. Thanks to this, at the beginning of each lesson, you can learn what problems you will be able to solve at the end of the lesson. This time, let's start defining the main objectives of this course in the context of external data management. I will keep the discussion generic to be broadly useful and portable. As usual, let's start by defining the main objectives of this lesson and outlining the topics we may encounter in the context of functional programming. I will try to keep the discussion general enough to be broadly useful, but to make it practical, all examples will be prepared using the C# programming language. Following the main aim, during this lesson, the following problems will be examined. Title explanation. An indispensable thing for enrolling in a video course is understanding the title. This topic is tightly coupled with the topic explaining the course scope. Scope. We must learn the scope of the course, allowing comparison with the requirements of your further career, and judgment on whether you are prepared to complete the course. Prerequisites. When learning new topics, we must assume that you have the expected basic knowledge. Hence, the next objective of this lesson is to gather a description of the basic terms the course is founded. Because definitions of the detailed prerequisites are difficult, it doesn't mean that, as an introduction to the subsequent lessons, new ones will be raised. They are tightly coupled with the listed ones and will not require deep studies. Unfortunately, terms like information and knowledge are abstract and cannot be directly processed by any physical device, including but not limited to computers. However, in everyday life, the terms data and information are often used interchangeably because both refer to a collection of facts. In other words, both convey a piece of knowledge. It is a simplification, but to clarify the course title, we can assume that the meaning of both terms is well known, and there is no need to provide a more detailed explanation. Unfortunately, in contrast, the terms information and data, which have fundamental importance, are not synonyms in the program engineering discipline and must be distinguished for many reasons. To learn more, consider enrolling in the Programming in Practice, Information Computation course. The lesson resources contain details on how to open this course. Computer science in general, and especially program engineering, is a field of knowledge that deals with the automation of information processing. Computers may be recognized as a driving force of that automated behavior. To achieve information processing goals, software has to implement algorithms required by the application in question. In other words, the software describes how to process information. An algorithm is a step-by-step process or set of rules designed to carry out a specific task or solve a particular problem. In other words, it conveys knowledge on how to solve a problem. However, since knowledge is abstract, it needs to be implemented for use by a machine, such as a computer. Implementation acts like a recipe that instructs a computer exactly what steps to take, in what order, to reach a desired result. This recipe must be written in a programming language that the computer can understand. Using the chosen programming language, a software is then created. In other words, the program is a text written in a specific programming language that represents an algorithm, which, again, is knowledge on how to solve a problem. Software development needs programming. To improve your programming skills, you have the following options. First, you may learn the programming language as the principal goal and start programming from scratch. It leads to a theoretical approach, and finally, possible improvements of your knowledge, but not skills. Second, the only solution promoting a practical approach is by using examples. Unfortunately, a typical approach could be described by the following scenario: if you need inheritance, reflection, serialization, dependency injection, and inversion of control, that is, just do it. And here you are getting a snippet of text illustrating how to implement the selected concept. It is like the Twitter-style deep thought expressed as a short text. Unfortunately, it teaches the humility of the teachers but not the skills of the students for sure. Additionally, this approach has a few drawbacks. By design, the examples are detached from the context. It means that they are not answering a question if someone needs something, and what this something means. Additionally, this approach doesn't promote reusability because, intentionally, the examples are tightly coupled with details that exist only in the teacher's mind. Sometimes, any simple modification of assumed details causes the code snippet to be useless for practical use cases because it is not self-contained. Third, concluding, teaching based on snippets promotes simplification. My point is that simplicity was not born by simplification. In other words, the examples are indispensable to make the learning outcomes practical, but to overcome the drawbacks mentioned previously, I propose extended examples. By the extended example, I mean examples that can be executed. This way, you can observe not only a pattern but also trace the behavior. I believe that it should also improve the reusability of the examples. Unfortunately, the full-featured program embedding an example usually has a lot of unimportant details for the topic at hand. It could obscure the pattern and make the behavior hard to understand. The good news is that I have a strong plan based on a trade-off between code snippets and full-featured executable programs. The plan is very ambitious, and the material is very extensive, so please prepare yourself for severe study rather than just browsing colorful pictures and watching my keyboard achievements. Let's return to the explanation of the course title. The title refers to external data management. For the title explanation, assuming that the term data is self-sufficient and understood by itself, we can move on to defining the term external data. External data is recognized as data that must be pulled or pushed from outside the boundary of an operating system process, hosting the computer program. Typically, access to this kind of data requires mediation between the program and the execution platform. In practice, for data processing, this mediation must be embedded within a programming language and its execution platform to enable seamless and portable programming that implements interoperability in the context of external data. In general, depending on the use case, the external data may be grouped as follows. Streaming, bitstream embedded as the content of files, or network payload. Structural, data fetched from and pushed to external database management systems using queries. Graphical, data rendered on graphical user interface. Separate course to manage the length of the classes, and better match the scope. Each of the mentioned groups is the foundation of a separate study. For example, graphical data is the main subject of discussion in a separate course called Graphical User Interface. Whereas, functional programming covers topics and tools that may be recognized as a foundation and introduction to structural data. Continuing the course title explanation, the next word of concern should be management. Data management involves the organization, storage, retrieval, communication, and manipulation of data to ensure its accuracy, security, and accessibility. It encompasses processes like data collection, storage architecture, integration, and maintenance to support efficient computer-based analysis and decision-making. The relationship between data management and functional programming is rooted in how data is represented, transformed, and maintained in software systems. Functional programming is a programming paradigm that treats computation as the evaluation of mathematical functions. It avoids changing state and prefers immutable data. We will encompass only selected topics that are related to structural programming. Concluding that the dependency of the data management on the mentioned topics is rather weak. To learn details related to data management, check out courses dedicated to discuss of streaming data, structural data, and graphical data. The last one has just been published by me. Functional programming is a programming paradigm in software engineering that treats computation as the evaluation of mathematical functions, avoiding changing state and mutable data. In other words, it is a programming style, also known as coding style. In practice, Functional programming is a set of rules embedded in a functional programming language and implementation guidelines that govern the templating of source code. It is believed that this style helps programmers read and understand code, maintain it, and reduce the likelihood of introducing errors. As a result, an improvement in robustness should be expected. It includes the following key concepts: pure functions, functions that always produce the same output for the same input and have no side effects, like modification of global variables. Immutability, data is immutable, meaning once it is created, it cannot be changed. Instead, new data structures are created. First-class functions, functions are treated as first-class citizens, meaning they can be assigned to variables, passed as arguments, and returned from other functions. Higher-order functions, functions that take other functions as arguments or return them as results. Recursion, functional programming often relies on recursion instead of loops for iteration. Function composition, building complex functions by combining simpler ones. Functional programming is often selected for software development because it offers several advantages that can lead to more reliable, maintainable, and scalable code. Modern programming languages support functional programming features. Hence, developers might choose this paradigm for a generic algorithm implementation. Whereas this course focuses only on selected solutions that might be applied to manage external structural data. This programming style can also be partially recognized in object-oriented programming languages. In general, this topic is far beyond the scope of our consideration. The only interesting thing, in external data management, is the possibility of decoupling the program behavior from the external data source managed by independent repositories, thanks to applying solutions that can be considered derived from functional programming. Hence, functional programming may be recognized as a foundation for processing external structural data governed by a database management system. The main goal of this approach is to process external data despite the program state, as a result of the main feature of functional programming that a function result depends only on the value of attributes, excluding all side effects. The DBMS is software executed on top of an appropriate execution platform used to organize, store, retrieve, and manipulate data in an organized manner. While managing data using a database management system, the following operations may be distinguished: create, add new data to a repository; read, retrieve existing data from a repository; update, modify existing data in a repository; delete, remove data from a repository. Execution of these operations is controlled by a formal description written down in a selected domain-specific language. For relational databases, usually, it is sequential query language or a derived jargon. Functional programming constructs of the main programming language are a good candidate to be used as an equivalent solution to define these operations. In this scenario, appropriate functions may be consistent with the rest of the program because they are expressed in the same programming language. To be executed, they are translated to an appropriate domain-specific language and sent to a target database management system. To deploy this solution, there must be a one-to-one relationship between the selected constructs of the source language and the destination language. Let's delve into the details of this approach backed by code samples. The most important behavior of a method compliant with the functional programming paradigm is that its output value depends only on the argument values that are passed to it while invoking it. In other words, the function behavior doesn't depend on the local or global state. So, invoking a function twice with the same value of arguments produces the same result each time. An example of the function conforming to this paradigm is, for example, the following predicate. This predicate always returns true if the current string assigned to string to test is longer than 10 characters. It represents the method that defines a set of criteria and determines whether the specified parameter meets those criteria. It eliminates side effects, which is a key motivation for using the functional programming approach to manage external data. In this scenario, the function can be sent and executed by a data management system, and produce a group of data that fulfills the condition. In the preface, not all explanations are supported by examples. Therefore, consider enrolling in the Programming in Practice, Information Computation course. The resources for this lesson provide details on how to access it. Again, analyzing potential solutions without appropriate examples makes the discussion too theoretical. Examples should be managed and presented using suitable tools to be comprehensive. I have done my best to ensure that the tools used to prepare examples do not impact the topics discussed. However, it cannot be completely ruled out that the tools may influence the solutions. Additionally, the choice of tools could limit portability to other environments. You should also have basic knowledge to utilize the selected resources. In any case, you must be aware of the chosen tools in advance. During the resources lesson, you will learn about prerequisites for opening and tracing the behavior of examples gathered in a GitHub repository. The link to this repository has been added to the lesson resources. Don't expect a deep dive, but rather a discussion on how to get started. To ensure a practical context for the discussion and provide solid examples, all topics in subsequent sections are illustrated using the C# programming language and the Visual Studio environment. The source code of the examples used is available in the X Data Management solution. The proposed principles, design patterns, and scenarios are intentionally generic and can easily be adapted to other environments, including but not limited to different programming languages. As the name suggests, the functional programming section focuses on selected concepts that support this programming paradigm. It must be emphasized that these are examined in the context of structural, external data. It includes the following topics: extension method, delegate and events, anonymous function. The extension method lesson covers key aspects of syntax and semantics of extension methods, with a priority on their invocation. Learning extension methods is highly beneficial for writing cleaner, more expressive, and maintainable code. Extension methods may be considered as added to existing types, even sealed or third-party ones, without changing their source code or using inheritance. They allow for fluent, chainable invocation syntax similar to instance method invocation, making code more natural and expressive. Extension methods have a significant connection to functional programming, particularly in how they facilitate function composition, immutability, and declarative coding styles. The main goal of the delegate and events lesson is to learn more about creating and using method references that are similar to method pointers. A method reference and a method pointer are concepts used in different programming languages, and they serve different purposes. Learning about delegates and events is crucial for mastering event-driven programming and creating flexible, maintainable, and decoupled code. Delegates and events enable different parts of a program to communicate without tightly coupling them. Delegates allow you to pass methods as parameters, facilitating callbacks. It is a crucial feature to deploy a coherent database fetching mechanism. Events are built on delegates, and are used to notify subscribers of a condition change. There is a strong connection between delegates and functional programming. The main goal of the lesson addressing anonymous functions is to examine this topic in the context of external data management. Learning about anonymous functions can be motivating for several reasons. By design, anonymous functions enable more concise and readable code, are a key contributor to functional programming, are widely used in event handling and link expressions, can reduce the overhead of creating separate named methods, and many popular frameworks utilize anonymous functions extensively to name only the most important ones. It is expected that students have a basic knowledge of the following concepts: information versus data, data as a representation of information. Binary data, a system that uses two signs to represent information as data. Algorithm versus program, a program is a text in a selected programming language representing an algorithm, which is, in turn, knowledge on how to solve a problem. Type concept, programming language constructs used to formally declare data, defining sets of allowed values and operations on these values. Anonymous type, types without a name that are defined by its properties. Partial definition, a concept allowing a declaration to be split into multiple parts. Generics, a type concept that allows you to define classes, methods, and data structures with a placeholder for the type of data they store or use. Code samples illustrating topics in this course are written in C#, developed using Microsoft Visual Studio, and managed using a GitHub repository. Hence, the following knowledge could be helpful to successfully finish the course. It could be useful, while using C#, to be familiar with basic language constructs, including but not limited to types, variables, instructions, namespaces, object-oriented programming concepts, including abstraction, encapsulation, and inheritance, and common libraries and frameworks within the language environment. To use Visual Studio effectively, you need knowledge of project and solution management, as well as debugging tools. To use a GitHub repository, you should be familiar with basic commands, clone, commit, push, pull, and understand branches and pull requests. This knowledge will be helpful in effectively managing code, developing applications, and collaborating with others in the context of this course, specifically with the C#, Visual Studio, and GitHub repository. That's all for now. Again, thank you for watching. To follow me, watch, or star the repository with the extended examples on GitHub. If you have questions or doubts, contact me via Gmail at programmingandpractice24. Let me invite you to visit my profile on C# Corner. Details can be found in the lesson resources. Again, thank you for your time. I look forward to seeing you again during the next lesson, which will address the resources used to maintain and manage the sample code, including but not limited to the motivation behind programming language selection, effective use of Visual Studio, and the applicability of the GitHub repository.